A lot of the PhET research shows that it's helpful if students feel a little more ownership of the sim and their learning.
Students view the sim as something that they're comfortable with and something that's there for them to explore and for them to really take meaning out of on their own.
Ownership is the feeling that you have control over something. In this case, your own learning.
Okay, so now let's just pick 5 ohms values.
Ownership can be very motivating, and motivation is one of the most important factors in helping students learn. If students are able to have a sense of control and choice, they are more likely to engage with the simulation and learn. Many of the facilitation tips in our other videos can be used to encourage student ownership. In this video, we will highlight 4 key ingredients for encouraging student ownership. Give students control of the simulation. Let students explore. Encourage students to share their ideas. And validate and use student ideas. Giving students a chance to play with the simulation is a great way to start them out.
So as you're playing with the sim, please remember, you cannot hurt the sim, you cannot hurt the computer, and you may try whatever you want out on the sim.
Christine started the activity with 5 minutes or so of open play, and she makes very clear to them that it's their tool to use. So she very much hands the ownership of that tool to her students in her introduction of the activity.
Generally, you want 1 or 2 students per computer so that everyone can have a chance to play with the simulation. It's also important to keep students in the driver's seat, even when you're helping them out.
One of the things that I found to be very effective, if I see that a student wrote something down that probably shouldn't be happening in the simulation, it's just a really easy thing to say, can you show me that?
I never touch the keyboard, ever. I never do. That's their thing, you know, so I'll come around and say, what if you did that, or what if you did this? But I never touch the keyboard. It's too easy to swoop in and take over, and then they're not learning it.
It can be kind of hard to resist, but when teachers do step in and start controlling the simulation on the student's computer, we see the students sort of sit back and become more passive and just less engaged with the learning process. What I try to do instead is think of a probing question to get at the idea I'm hoping that they'll reach.
Wow, so what was different about that motion as opposed to the motion when you just turned off the gravity before they began moving? Move faster? Try it again, think about it.
You can explicitly build student exploration into your activity design by minimizing direct instructions. Instead, include questions that gently guide students in their inquiry.
One thing I try to avoid is telling students exactly what to do, and I don't tell them things like push the slider this way or push the slider that way, because it turns into a cookbook experiment too easily.
Instead, asking questions or posing challenges that gently guide students can more productively spark exploration. You can find out more about activity design in our video, Designing PhET Activities. While you're helping students work through the activity, you can use open-ended questions to guide students in their learning.
I go around, I don't give them the answer, but I'll probe them. Well, how do you think you might do this? And with younger students, asking them what they think they know really helps kind of build their confidence about it. Because of what law?
Law of conservation.
Okay, so law of conservation of energy. So how does that apply here? Where's the energy from the battery getting?
It's going into the bulb and coming out as light.
Okay.
What was your observation that you made between the two of those?
That when it uses wires, it lights up brighter, and when it uses a resistor and a wire, it barely lights up.
Right, so what do you think a resistor does?
It gives the minimum light.
But why? Use what you just said. The observation that you made that it's making this go slower. What does a resistor do?
For more information on facilitating students as they work in small groups, see our separate videos, Circulating and Checks for Understanding. Supporting students in sharing their ideas can be a powerful approach for creating ownership.
If I think a sim might have some little hidden things, I'll challenge them. I'll say, try to find some things that you think your neighbor might not find, and we'll share those out in a little while. Okay, so I see you guys haven't figured out what to draw for the initial condition. What did you ask Mason what he did?
What?
No. Okay, ask Mason what he did then.
Mason, what did
you might have to get up and go look at it. I don't know.
Another opportunity to encourage students to share their ideas is when a classmate needs help.
One of the things that I've noticed that's really helpful is to say, I wonder what Jose did in that situation, and prompt that student dialogue to really help students maybe get past a place that they're stuck.
While students are working on the activity, listen in on student conversations.
Use those insights to facilitate classroom discussions that are generated out of those student ideas. So the students feel like their ideas are advancing the classroom's lesson and are really being heard.
You might do this by using a student's findings that you noticed as you walked around the room.
As I see students doing really great things on their own computers, I can ask students to go to my computer, which is hooked up to the smart board, and recreate what they've done so that we can use that as a whole class discussion. So who would like to show us what you did? Angel? Recycling. Yep. Go ahead and take it. Thank you guys so much. However, Angel made a really good observation earlier about how he knew that it wasn't just like gravity was off and that the Earth had flown away. Angel, can you share that with us? How do you know that the sun and the Earth are still pulling on each other, even though we can't see the Earth on our screen anymore?
Because it shows up here that this was pointing that way, not pointing that way.
So we can see that gravity.
If students are at a place where they're not yet able to express their ideas fully in words, they can use the simulation to show what they're thinking. Teachers can use these opportunities to support students in developing scientific communication skills.
What is the geometry about that symmetry? And you had it before.
So wait, is it just one carbon?
Yeah, remove it.
Is it just this?
Yes.
This one? Just that?
Yep. And what's its geometry?
Linear.
Responding to student ideas in a supportive way can help boost students' confidence and feel that they're able to master difficult concepts.
In particular, in observing Christine, she was excellent at making it clear that she truly valued student opinions. One of my favorite phrases that she would use is, "Oh, I really like your thinking." She would more take in what they were thinking and try to have them re-express it in a way that fit with the learning goals of the day.
I think it's really important to be really open and flexible to things that students that are bringing that they've discovered.
So, to help students feel a sense of ownership with the simulations, you can give students control of the simulation by letting them play with it and not getting in their way. Let students explore by gently guiding students instead of giving them direct instructions. Encourage students to share their ideas with each other. And validate and use student ideas by listening to what they say and using those ideas to further the lesson.
Other things that I liked, probably like on top of just like being able to visualize what's happening, is kind of being able to test like whatever you want, basically. Like having a lot of control on like how you're experimenting with what's going on. I think that was really cool.